binary file operations. Till now, whatever programs we have written or executed in files, we are either saving as .txt only, okay, but there are so many other formats supported. But for just for basic understanding, we are seeing text file, but I will maybe once we complete the theoretical part, we will be discussing some previous placement questions or some dump of programming questions like we have seen in linked list or other concepts of C++. We will be seeing sequence of problems. There we will explore different text formats. Okay, so one such format is binary file. Okay, with .bin extension. Why we have to study binary files? I think you are aware that C or C++, right, when you compile, it is converted to the machine level, right, binary language. It is converted to binary language, right. That binary language is understood by the machine. Okay, so in this approach, we actually to store whatever in your RAM, I think you are aware of this, in your hard disk or in your mobile you say 8 GB RAM, right, you say 128 GB hard disk or this memory space, you say like this. So in the whole memory, whether it is RAM or the hard disk space, right, whatever you are storing, it is stored as binary only. Okay, in whatever data you are storing in your memory, whether it is primary or secondary memory, it is always stored in binary format. Okay, even if you are taking a selfie picture and if it is stored in your mobile phone, that is stored as binary only. Whatever movies, videos you are saving in your laptop, they are stored in binary format only, right. So that is default one. That's what our I think you might have studied this in programming or maybe basics of programming, like bits, then byte, right. So many concepts. Why? Because everything is stored in memory here in bytes. Again, it means in bits only. Okay, so whatever data you are storing, it is stored in binary format only, that is zeros and ones, 0 and 1s. Okay, so we are trying to talk about another file type, that is bin extension .bin. It indicates .binary, binary file. What is the use of this? Let us see. Binary file operations in C++ allow you to read and write content in binary mode. Okay, treating the data as raw bytes rather than human readable text. So whatever, suppose I am storing hello keyword, HELLO, or let me take a small h here, HELLO. This h has some ASCII value, that ASCII value is a number that has some binary value, that binary will be stored here. Okay, I will show you the demo how these values are stored. So this binary file, maybe abc.bin file, will have all zeros and ones like this, all zeros and ones. Okay, why do we have to study this binary file? Why we need that? Because binary files are commonly used for storing images, audio, executable files, data, whatever data you want, right. You can store only in the binary format. Okay, so where precise control over byte formatting is required, means when the data is stored perfectly in binary bits. Say suppose I am having H8E7O, this is my string, I want to store this in my file .txt file. Okay, so how is h is stored like this, 8E70, normally they are stored like this. Now when I use my seek functions, seek g, seek p, when I use, I am saying give the number of bytes, give the number of bytes. So if suppose I give the number in seek g function, let me take one example of seek g. In seek g function, I am giving here some 7. Okay, let's take 8. No, let me take number of bytes. I may give 3. Let me take 3 bits, iOS and begin. Let's see this example. Begin. What will happen? This is 1 byte. This occupies 1 byte. What about 8? It occupies 4 bytes because it is integer. Depends on the compiler, but still let's assume 4 bytes. Then this is 1 byte. Then again this is 4 byte. Then this is 1 byte. Now when I say move to 3 bytes, where will it move? 3 bytes means h 1 byte over. In 8 it has 2 bytes. It will move after 2 bytes in 8. So if I print the content at that location, it is not proper, because again the story here is 8 will be stored in 32-bit format. Okay, so it will all zeros, so on zeros, and at the end I will have 1 0 0 0. This is my 8. Okay, so when I move seek G 3 bytes, means first byte is gone by H, second byte by some 8 zeros, the third byte again 8 zeros. After there my location will be pointing out. So when I print that value, it may not give a proper value. So there is a chance of no mismatching, not giving proper data, right? Because half of the maybe that number is a very large number. For example, I have the string like this. I have H 999999 as a number, and then I'm having E, then 7 and 0. This is a very large number, so it will have so many binary locations like this one. This is being missed. So there is chance of some misbehavior. Why? Because when I'm giving seek of 3, it has to move 3 bytes. 1 byte is gone here, 2 bytes from this. So number of bytes it will move, 1 byte and then second byte, from that will pointing out. It is not proper. For that reason, what we are trying to do, we are trying to store every content, whatever you want to store it in binary format. Store that in binary format so that you get precise values. Okay, you get the precise values. So generally we know that images, why images, how images are stored in binary file. Image is nothing but it's a collection of pixels. This is passport size photo. If this is some face here, something like this, there exists a passport size photo. Okay, right. In this case, everything is a pixel. There are so many pixels here. Every dot here is a pixel. We call it as pixel. I think you are aware of this mobile phones pixel. When you purchase camera, you will see. When you purchase camera, you will be seeing about pixels, right? So what is the pixel size? That all you will vary. So every image is a collection of thousands of pixels, and each pixel is a 3 by 3 matrix. It's a 3 by 3 matrix of zeros and ones. 1 0 0 like this. It is a collection of 3 by 3. Each pixel is a collection of 3 by 3 matrix. It means if suppose this image has 100 pixels, it means there exists a very large matrix. Because first pixel is 3 cross 3, then second pixel, then third pixel, then fourth pixel, and so on, right? So that way this image is stored in your hard disk, in your memory. It is stored in binary format. Okay, so we use to store images, audio, everything we use binary format. Okay, we will anyhow try to implement and see some simple examples to understand how these binary files works. Okay, let's explore more about these binary files. Now the fourth mode is iOS:binary. I think you remember we are having other 3 modes like in, iOS out, iOS append. We have studied about these 3 modes for basic text files, in, out and append mode. Now you have the fourth. Modes are not yet completed. We have so many modes. The next mode is iOS:binary mode. It means it will store the content and read the content only in binary format. So you have to open a file with, open a file in binary mode using binary flag, iOS scope resolution operator binary flag. Then instead of using to print and to write content, here it is very easy for us. We have a read function to read that binary data, your write function to write the binary data. Okay, if you want to read some content, you can directly use read. So maybe just to make your learning easy, what we are doing, we are creating f stream. I am creating one object f. Okay, then f dot open. I am creating a file abc.bin with which mode? Binary mode. So iOS:binary. Okay, I wrote that binary here. Then you can simply use f dot read. You can use f dot write. Okay, you have to give location here, that I will tell you, but you can use like this, read and write. So using this object f, of fstream class. You can directly write read and write like you are writing seek G and seek P, tell G and tell P. Same way you can do it here. So this read function, name itself, it is self-explanatory. It says it is used to read the content of that binary file, and write function is used to write content to the binary file. We will see more examples. I will give with some examples. I will explain you that read and write. Okay. So syntax again, if stream, if you are using, see, file name dot bin iOS binary. O stream you are using, O stream itself directly it means for writing. I think you are aware of this. If stream is meant for reading and OF stream is for writing. Okay. So that's why if stream, if I give file name dot bin, you have to use iOS colon binary. We are not specifically giving this iOS in mode. We are not giving in mode. Why? By default, when I use fstream, it is in mode only. That is for reading. So binary. OF stream, OS binary. Or you want to create using fstream, you have to give file name dot bin. You have to give in, out, and binary all. This is for both reading and writing. This is for both reading and writing. Okay. Just understand the syntaxes and the process. We will try to see the example programs. So if I repeat, binary files, actually there is a problem with the storing of content. If you want to store some large content like audio, video, or images, right? It's all anyhow in our computer memory, it is stored in binary format. That's why we are trying to store the content in binary format and read the content in binary format. Okay. Instead of putting that in text. What is happening in text format? When I am doing text format, when I am putting here 1, 2, 3, indirectly this is again converted to binary and the processing is being done. So to avoid faster access, store the file as a binary and store the content. Do whatever operations you want to do in that binary file. Okay. So let's go see the functions here. What are the operations in this binary file? First one is write. To write a content to the binary file, we have used write function. Okay. What writes raw bytes to the file? There exists a file dot bin with extension dot bin to write content. Even though, see, when I execute this program, like we are doing in C or C++, what we are doing, addition of two numbers, we are giving 10 and 20 only. But internally what the compiler is doing, converting this 10 and 20 to binary format, binary language, and then giving this binary language as input to the program for that machine. That machine is understanding only binary language. Normally I am giving 10, 20 only, and from a naked eyes I can see 30. That is normal human readable numbers, what we know. But internally what compiler is doing, it is translating, it is converting that high level to binary language or machine level language. So write function input, for write function I will be giving input as 10, number 10 only, but it will write, it will convert this 10 to binary and store that in binary here. When I extract this, it will give me 10 only directly, but the content of the file when you open and see, it is in binary format. Okay. So what is the function use of this write function? Writes raw bytes to the file. Writes raw bytes to the file. It requires two arguments. First one, a pointer to the data to be written and number of bytes to write. Okay, two arguments. Let's see this example. Let's understand how this write function works. Anyhow, we'll see the programming of that. So int numbers, I am creating an array 1, 2, 3, 4, 5. I am creating an array with numbers 1, 2, 3, 4, 5. Now this is the object which I am creating. Write, see, out file, that is the object which I am creating for that f stream. Then write function write. I have to give the pointer, see, char star numbers. Why I have to do this char star? It is typecasting, it is converting this integer things into characters. Why to characters? Because we are storing everything in bytes, no? We are storing everything in bytes, right? That's what byte again means, binary bits only, zeros and ones. The name says binary, but we store in bits, zeros and ones. So the syntax is write char star numbers, that is the name of this. Size of numbers, how many numbers are there? 5. So that will be given. Size of numbers means 5 into 20, it's 5 into 4. Size of number, what is the size of how much memory is allocated for number? 20. So this is 20. Okay, so it will be creating 20 bytes in your file, some binary file, it will be creating 20 bytes. Okay, this is just to introduce you how the write and read function works. See the read function, read, it reads the raw bytes from the file. Again, it requires two arguments, same pointer and number of bytes to read. Syntax is same as your binary write function. So in file, why in file? Because to read I have to use if stream, no? To read I have to use if stream. So in file object which belongs to if stream class, then read char star numbers and size of numbers. So this will read the contents of the file. Okay. So for your naked eyes, again I will repeat, for your naked eyes, this binary file operations, whether you are inserting integers, whether you are printing integers, whatever you are doing, you will be giving from your keyboard numbers, normal numbers only. But the way it is stored inside the file, it is different. That is in binary format. That's the only change. For giving input, for taking output, everything is normal. You will see integer numbers only or characters only, like you have been seeing for the other formats of files, text format or Excel or CSV, whatever, right? But for binary, the only thing, it is converting and storing into in the file as binary bits, zeros and ones. And when it is giving back to me, it is giving normally as my normal numbers, integer numbers like this, 1, 2, 3, 4, 5. Okay. The only thing here is that, right, it is mostly used, so to get the precise values, we use this binary file operations. It has lot of benefits. On binary files also, you can use this random access. Okay, we will let's see the demo of how to use this read and write, basic read and write on binary files. Then we will go for how do you access sequential and random access of binary files. Like we have seen for normal files, we will also see for binary files. But now let's to understand it much better with implementation, let us see how to create a binary file, how to write content into binary file, and how to print that content from the binary file. Okay, to see how do we write the content, we have to use a write function and you have to use a read function to write to read the content from the binary file. Let us try to see that using demonstration. So this is about binary file operations, basic understanding of binary files.